GCSE question of the week, week 18. Loads to do. Foundation first. Change into decimals. A, 3/10. Well, there are loads of ways to do this. Easiest is, what does 3/10 mean? It means no units and 3/10. So A is 0.3. Okay, if you're not sure about how to do that, do what the 3/10 says. It says 3 divided by 10. That line means divided by. So 3 divided by 10. How many 10s in 3? None. Carry the 3. How many 10s in 30? 3. Oh, we're done. We get 0.3. Same answer. Calculator paper. Really shouldn't be on a calculator paper, but 3 divided by 10. 0.3. Stick it in as a fraction. .3. You get the idea. Okay? 3/10, 0.3. B. 3/100. Well, we could do it in all of the same ways we just tried. Easiest, 3/100 means no units, no tenths, and 3/100. It's 0.03. Could do the same thing. 3 divided by 100. 103, none. Carry the 3. 130, none. Carry the 30. 100 into 300, 3. 0.03. Okay. 3/100. As to D. 0.03. All of those ways will work. You need to know them. Okay, number 2. This trapezium has one line of symmetry. I assume that's got to be there. Find the value of angle DAB. Right, really, this should have an angle symbol or a little angle hat there. Angle DAB. So DAB, that's the letter in the middle. We're looking for that angle. Okay, we know a couple of lengths. We know the height of the trapezium. We could work out the area of the trapezium. That's not what we want. We want an angle. Okay, so as soon as I know I need an angle and I can't see any other angles in the diagram, I'm thinking maybe some sort of trigonometry. Okay, and we know with trigonometry you can only use a right angled triangle. So I'm thinking, could we split the shape into something like that and that? We get a right angled triangle. So that's the key point to get going. So let's make a sketch. We're going to turn that into that. This is the bit we want. Okay, we're really interested in that triangle there. So let's just focus on triangle DA, and this bit's not B because B is way over here. Okay, we could call it X. Okay, and we've got angle. Let's call it angle A here. Angle DAB. Right, what do we know? Well, we know this height is 4.2 centimeters. But if we're going to use trigonometry, if we're going to use SOHCAHTOA, and we want to find an angle, we need to know two other sides, and we don't. So we don't know the hypotenuse, which is here, and we don't know the adjacent, which is here. We do know the opposite, which is here. So we better try and work out either the hypotenuse or the adjacent. And how can we do that? Well, we know this is 9 centimeters. And we know this is 16 centimeters. So if I take away the 9 from the 16, equals 7 centimeters. What would that 7 be? Well, that would be that length and that length. So those two lengths plus the 9 have got to make up the 16. And those two lengths are worth 7. So how are we going to find out one of those lengths? Let's divide by 2. 7 divided by 2 equals 3.5 centimeters. So we know this length here is 7.5 centimeters. Sorry, is 3.5 centimeters. So we know A. A is 3.5 centimeters. Brilliant. Now we know what we need to know. Okay, we're looking for angle A. We know the opposite. We know the adjacent. What do we need? SAW, CA, or TOA? Well, if we want the opposite and the adjacent, we better go for the TOA. We better go for tan. So we need tan. Tan of what? Well, tan's always of an angle, so we need tan A equals opposite over adjacent. So tan A, tan of angle A, is equal to, what's the opposite? Oh, it's 4.2. What's the adjacent? Oh, it's 3.5. So tan of angle A, the tangent of angle A, is equal to 4.2 divided by 3.5. How do we get angle A? Well, we need to do inverse tan. We need tan minus 1 of 4.2 divided by 3.5. And that's going to tell us angle A. So, let's pop up the calculator. Clear. What do we want to do? We want inverse tan. I need shift tan. I want the little orangey yellow tan minus 1. So shift tan, and then what do we want? We want, you can put it in as a fraction if you like, 4.2, not 4.2 divided by 3.5. And we can close the brackets. Right, like that. It's better. So we've got inverse tan, 4.2 divided by 3.5. What does it give us? Fantastic, 50.19. Okay, so angle A is equal to 50 point, let's call it 50.2 to one decimal place. 50.2 degrees. Okay. If you prefer, we could have done 4.2, keeps doing that, divided by 3.5. Right, 6/5, 1.2. That would be the tan of angle A. So what do we do from there? We inverse tan it. Shift tan of our answer. It's going to give us the same thing. Okay, but if we're finding an angle from trig, we're going to need the inverse function. Inverse sine, inverse tan, inverse cos. Okay, 50.2. Okay, next question. Find the exact value of, okay, the square root of cos 40 subtract tan 25 all over tan 80 minus sine 35. So get a school type calculator. It makes it so much easier. Okay, what are we going to do? We want square root. Let's go for that. Okay, we've got some sort of fraction inside that square root sign. So we'll choose the fraction button. Okay, what do we got on the top? We want cos 40. Now we don't need to enter the degrees. Your calculator's set to degrees. It's already going to assume we've got degrees. That little degree sign we don't need to worry about, but we do need to close the brackets. Subtract tan 25. Close brackets. Let's just whiz back, see if that looks right. Yeah, that looks like on my page. Let's use my purple circle to go down. We want tan 80. Close the brackets. Subtract sine 35. Close the brackets. Scroll back. Right, just make sure yours looks exactly like the one on the paper. If it does, we can't go wrong. Okay, mine's looking good. Let's press equals. We get 0.2424 blah 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 blah. Write down all the figures on your calculator display. Oh, 1, 0. Point. Just go for red. 0.24 2483 2483 7592 7592. Okay, now if it says write down all the figures, write down all the figures. It wants to know you've done it exactly right. Okay, it wants to know you haven't done any rounding at all. Now if you've got a different sort of calculator, you can't make your display look like that. You may have to go cos 40 subtract tan, and then we'll have to either put it in the memory or do it in bits. Okay, we've got to put brackets. In fact, I probably should have started with some brackets. Just get one like the one that we're using here. So much easier. Okay, right, round your answer to 3 sig figs, 3 significant figures. So we know we've got 0.2424, blah, 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 3 significant figures. Right, 3 significant figures. Right, is the leading 0 significant? No, don't count it if it's a 0 that comes first. Okay, the first significant figure is that one. that one, that one. Okay, so we want 3 significant figures. They're the ones we're going to quote. That makes this my decider. Okay, so my decider tells me whether to round that 2 up. Because the deciders are 4, not 5 or more, we're not going to round the 2 up. So 3 sig figs, we've got 0.242. Done. Okay, number 2a, solve 3x squared equals 75. Right, let's go up here. So 3x squared equals 75. Right, what do I want to do to the left hand side? I want to divide by 3. If I divide by 3, I'm just going to get x squared left. That means I've got to divide the right hand side by 3. 75 divided by 3. That's 25. So we've got x squared equals 25. Okay, now it would be tempting now to say that, wow, x squared equals 25. What times itself makes 25? It's 5. And you'd be right, but that's only half the answer. Okay, what we need to do is square root the x squared, just leave x. Okay, so we're going to take the square root of both sides. That's going to give me x on the left. And yes, it's going to give me the square root of 25, but that could be positive or negative. So in other words, what I'm saying is, it could be plus 5, or it could be a minus 5. Now why is that? Well, that's because 5 multiplied by 5 gives me 25, so the square root of 25 is 5. But also minus 5, because minus 5 times minus 5 is also equal to positive 25. Minus times a minus is a plus. This is also going to make plus 25. Okay, so there are 2 solutions here. X is either plus 5 or minus 5. X equals plus or minus 5. B, expand and simplify. Right, got double brackets here. This is looking like a FOIL to me, or a grid method, whichever you prefer. 3x plus 5 multiplied by 2x minus 1. Okay, right, if you need some FOIL practice, look back at one of the earlier videos. Right, I'm not going to do all the different coloured lines. I'm going to assume you know what I'm talking about. So we're going to do the first. It's 3x multiplied by 2x. That's going to give me 6x squared. I'm going to do the outers. That's 3x multiplied by negative 1. That's minus 3x. I'm going to do the inners. That's plus 5 multiplied by 2x. That is plus 10x. And I'm going to do my lasts. That's plus 5 multiplied by negative 1. That's minus 5. Okay, we've expanded. Woohoo! Okay, we've got rid of the brackets. Have we simplified? No, not yet. Okay, we can simplify by saying, well, we've got one x squared term, that's 6x squared. No others, so we can't add or subtract any. But we've got minus 3x plus 10x. That's the same as 10x subtract 3x. It's going to give me plus 7x. And there's nothing I can do with a negative 5. Okay, we're done. Have we simplified? Yay. Okay, we've expanded. We've simplified. 6x squared plus 7x minus 5. Okay, factorise x squared plus 8x plus 15. Okay, so this is a FOIL in reverse. Here we've got to put some brackets in. So we're going to get something like our starting point in part B. We're going backwards. Alright, so if you know the drill with these, we've got a pair of brackets. We know we're going to put x at the start of each one, because x multiplied by x will give us this term here, our x squared. And then hopefully you can remember the rule. We're looking for 2 numbers, okay, that multiply together. Their product multiplied together gives us plus 15. And when we add them together, they've got to give us plus 8. So they multiply to make the end number here, the plus 15, and they add together to make this plus 8. So what are those numbers? Okay, what are our factors? Okay, well, I think we could use 1 and 15. No, not going to work. We could use 3 and 5. That sounds good, because 3 plus 5 makes 8. So I think we're going to need x plus 3 and x plus 5. Okay, right, now to verify that that works, I'll leave it to you to now expand x plus 3 multiplied by x plus 5, and hopefully you should verify that if you FOIL or grid method it, you get x squared plus 8x plus 15. So we've factorised. Well done.